Welcome to the STEM Digital School. This is Natural Sciences and Technology for grade 4s. So guys, my name is Onkarabetse Setswe and I am your teacher. We will be continuing from where we left off yesterday. We've been dealing with matter and the materials, and the topic that we have been looking at is materials around us. Okay, so just before we start, I see Zoe and Michaela, your hands are raised. I don't know if you guys have a question, maybe. If you do have a question, just write it in the group chat, then I'll attend to it. And I see Jordan or Jordan, you've been asking for Kahoot, if we can play Kahoot. Guys, I will find out. And if we can play Kahoot, we will most probably do Kahoot on Fridays. Okay. But right now, let us just go through the lesson. And if it is possible for us to play Kahoot, we will play Kahoot on Fridays. Menintle, your mic is on. I don't know, do you have a question?
No, ma'am.
Hi.
No, I was just wondering when we were going to start the lesson.
Oh, okay, no. Lesson starts at 12 on the dot. Okay.
Okay.
Sure.
Thank you.
Sure. All right. Okay. Right, guys, just a quick recap on what we did yesterday. So yesterday we looked at change of state. All right, so we said that as spaces between particles change, the substance changes from one state into another. All right, and these states that we are talking about is the solid state, the liquid state, as well as the gaseous state, or the state in which we find gases. Okay, so we said that solids, they have a definite shape, and it takes up a definite space, and they do not flow. All right, an example of solids, big boulders of rock, and some of you guys also gave me examples yesterday of solids. And then liquids, we said that they have no definite shape, all right, but they do take up a definite space, right, and they can flow. Then we have gases, which have no definite shape, all right, and they take up all the space that is available to them, and gases can flow. An example of gases are the helium gas, which is found in balloons, that causes them to rise. Okay. Then we also said that when a solid is heated and changes into a liquid, we say that it liquefies or it melts. Okay. And then for a change of state to occur, we need to either add or remove heat. Okay. And then when putting water in the freezer, we remove heat. And then when we put water in the sun, we add energy. You guys can just remember from the example that we covered yesterday about the ice cubes. Okay, so when a liquid is heated and changes to gas, we say that it evaporates. Okay, so I see a hand is raised. I will attend to it now. Let me just finish here. And then gas cools and changes to a liquid, we say that it condenses, right? Then when a liquid cools and changes back into a solid, we say that it solidifies or freezes. And this is the example that we covered in yesterday's lesson. All right. Let me just, because I can't pronounce your name here, what is Apello? Do you have a question?
Ma'am.
Yes.
When
What's your
we
name? Let's start there. What's your name?
My name is Yoma. This is my father's profile.
Oh, Yoma. All right, cool. Yes, Yoma.
So, ma'am, when blowing balloons and they don't fly, but when I go to shops and I buy balloons, how come they float? What do they put inside them?
Okay. So the gas that they put inside the balloons in shops is the helium gas. So when you blow in the balloon, you are blowing out your carbon dioxide and so that's why it doesn't fly. Oxygen gas is the one that causes the balloon. Helium gas is the one that causes the balloons to rise. Okay.
Thank you, ma'am.
Sure. Yoma, right? That's your name.
Yes.
All right. Beautiful. Okay.
Ma'am?
And
Hi, ma'am.
hello. Okay.
So say, ma'am, what if to change to make a change of state, you have to use heat, remove heat, or remove or make heat.
Okay. Please repeat your question again.
Ma'am, if so for like a liquid or for a solid, say if you don't need, is there a different way to make a change of state instead of removing heat or putting it in heat?
Oh, okay. So your question is that can we change the state of a liquid if we don't add heat or remove heat? Are there other means in which we can do this? Okay, so basically, guys, it's very much important that the particles of your liquid or the particles of your substance, and we are going to use water as an example. Water cannot change from being a liquid to go to a gas or to go to a solid if we do not add or remove energy. Okay, so and the energy that we talk about is in the form of heat. So a state of change cannot occur if we do not add or remove heat. Okay, so heat is necessary. All right, heat is necessary. I hope you got that.
Ma'am,
I hope you got that. Did you get your answer?
uh, yes, I have another question.
Oh, okay. What is your name? I can't
Uh,
see.
It's Gabriel.
Oh, Gabriel. Okay. Yes, Gabriel.
Uh, Say, ma'am, is there different energy that we can use then? Is there a different
No.
energy?
Like for example, kinetic energy or potential energy. We need energy in the form of heat. So even if we use a different type of energy, the energy will be transferred to heat. Okay, so that the particles will gain energy and will split or come or lose energy and come closer together.
Oh, thank you, ma'am. No more questions.
Okay, beautiful. Yes, I see Zoe, your hand is up. Yes, Zoe?
Ma'am, it was a mistake.
Okay, you can mute your mic, it's okay. Then Bandile, your hand is also up.
How do they get fridges to be cold?
How do gases?
How do they get fridges to be cold?
Or how do they get fridges to be cold? So what happens with a fridge is that they lower the temperature of the fridge, okay? So we know that room temperature is about 25 degrees Celsius, okay? So, but then in a fridge, we get the special elements that cause the fridge to have a lower temperature. Okay, so that's why if you look at the difference between your deep freezer, the one where you usually put the meat, and you have another section where we just put random food, cold drink, and all that, the temperature in both of them differs. So in the deep freezer, we lower down the temperature. So there's just special devices that make it more cold. All right,
Thank you, ma'am.
beautiful. Okay, so this is the last question that I'm taking for now, and then we will continue. Okay, Jordan, oh, you're done, I think. Do you have a question?
No, ma'am.
Okay, so your hand is up. I guess it was a mistake. Right, cool. Let us continue. Or I think Nolly has a question. Yes. Hello? Nolly? All right. I think that was also a mistake, but we will continue. All right. So guys, we are continuing with a change of state. Okay, so yesterday we dealt with melting, okay, or liquefying, as we can also call it. And today we'll be looking at evaporation as well as condensation, okay? So guys, when we were dealing with melting, melting was a change of state from a solid to a liquid. Very much important that melting occurs when we have a solid and that solid is turned into liquid. Remember the story of Mashudu that we shared yesterday, where Mashudu bought ice lollies or popsicles, right, which melted in the sun and became liquid. Okay, so very much important to note that. Okay, so we're gonna do an activity, and guys, please use the group chat for academic purposes. All right. So if you have a question, maybe to ask me, or you are giving me an answer to something, just use the group chat for that. And let us not just have chit chats around. Okay. Let us concentrate on the lesson, please. Okay, so now we're gonna do an activity which will be based on heating and cooling to cause a change of state. Okay, so I see Michaela says, ma'am, can you go back? Okay. I believe this is what you wanted to see, Michaela. I said yesterday we dealt with melting. Today we'll be looking at the process of evaporation as well as condensation. Okay. So Menendla, I see your hand is up. Can you please use the group chat just to quickly write your question there? All right. Okay, so guys, let's get on with the activity. So guys, this is the materials that we're going to need now. A kettle, liquid water, a glass or a mirror, gloves or a towel. Okay, and we have the following instructions, and they read as follows. This activity could be quite dangerous as you might burn yourself with hot water. So please, guys, do not try this at home alone. Okay, so if you have, or rather, I believe you do, just ask someone older who is around the house if you want to do this activity or this investigation to help you with it, okay? So that you do not burn and so that you don't have any casualties that might happen. Okay, Toby, you have a question, just put it on the group and then I will answer your question. Okay, just put your questions on the group, guys, then I will answer your questions. Okay. So the instructions, they read as follows. We add the second partner. It says you boil the water in the kettle. And then the third one, it says put a glass or a mirror 30 centimeters above the boiling kettle. You need to wear gloves made of thick material or use a towel to avoid burning your skin. And then the fourth instruction says your teacher or anyone who's helping you who's older will then let you come to see what is taking place. So you need to make sure you have a look at the mirror or the glass that you will be using. Okay. So I see Noli is saying, what does evaporation mean? Okay, Noli, we will get into evaporation in the later slides. Okay, so I will explain what evaporation means. Okay, so guys, this is basically what would be happening. You have your kettle here, and then an elder who would be by your side, of course, will be holding up a mirror or the glass, just like it is indicated in the picture here, and they'll just be holding it up 30 centimeters above the kettle that has boiled. All right, and this is basically what you would see if you perform this experiment or activity at home, right? So this is how the glass would look like. So this glass or the mirror, it's the one that is held up there on the kettle, okay? Okay, so then we have questions that follow. Okay, I see says my name is Nati. Yebo. Okay, Nati, I get it. First question, what was the change of state when the water boiled and became steam? What was the change of state when the water boiled and became steam? So you guys can use the group chat to send through your answers. Okay, Toby, I see your question and I will answer it. Okay, so let's just go through this answers first, and then Toby, I will answer your question afterwards. Okay. So I need answers for this, guys. What was the change of state when the water boiled became steam? So I see Carol said evaporation. All right. Menenka also said evaporation. And then Bandile says, I did this last term, evaporation. I'm glad you remember Bandile. My name is Lone. Okay, I'm sorry about that. Okay, Lone. Okay, so clearly some of you guys remember this and you said that it is evaporation. So the change that happened was from being a liquid to a gas. Okay, so that is the change that happened when the water was boiled. It changed from being a liquid to a gas, and that is evaporation. Some of you guys also mentioned or rather asked the question, what is evaporation? So this is when we have a change of state, evaporation rather, is when we have a change of state, okay, from a liquid to a gas. Okay, so I can't remember who asked the question, but I hope your question is answered now. Okay, next question. You cannot actually see the steam, right? But in some cases, guys, you can see steam, but the steam is extremely hot and quickly cools and forms tiny droplets in the air. When the steam changes into tiny water droplets, what is this called? When steam changes into tiny water droplets, what is this called? So you guys can use the group chat to send through your answers. When steam changes into tiny water droplets, what is this called? Yes, there is a change of state occurring, and what is the name of the change of state? Okay, so I see Menentle, Bandile, and Siabonga. They say in condensation. Right, let's see if you guys are correct. And that is correct, guys. It is a condensation. Okay, so just earlier on, before we continue, Toby asked a question saying, ma'am, can you tell me how does water freeze? Okay, so Toby, guys, just make sure that your videos are off, okay? So Toby, how does water freeze? As we looked at it yesterday, right? Yeah, we did look at it yesterday. We have liquid, right? And the particles in a liquid are arranged in a particular manner. They can freely move. So when we put water in a freezer, these particles lose energy. Okay, so we remove energy once we put the water in the freezer, and then it solidifies. Okay, so that is how water freezes. Particles of water would lose energy and will just come together and be in a fixed position or in a crystal lattice. Okay. And then that is when the water solidifies. So I hope, Toby, your question is answered. Okay, guys, so we can just continue. And this is what we call condensation. I'm sure you guys have seen how condensation also occurs after having a long night, right? Your windows would also just look something like this. and it usually happens when it is cold, right? Okay, evaporation, guys, just as we dealt with evaporation just on the earlier slide, it takes place when heat is added to the liquid. So remember, guys, when we added heat to a solid, yeah, the solid turned to be a liquid. And when we add heat to a liquid, then evaporation occurs and the liquid changes into a gas. All right, so very much important to note that. And it means that water changes from liquid to a gaseous state. And here we have an example of where evaporation takes place. When we hang our laundry outside, then we are adding heat to the particles of water that are present on our laundry, and the water will eventually evaporate and our clothes would dry out. Okay. I see Meninja and Michaela, your hands are up. I'm just going to lower them. And if you do have a question, just put it on the group. Daresh, your hand is also up. I'm going to lower it, just put it on the group. Okay, and Gabriel and I think it's Lone. I think, yeah. Just put your questions on the group chat. Okay, then I will attend to them. So guys, if you do have a question, just put it up on the group chat. Toby, I think you also say you have a question. Just write it down, please. So write it down on the group chat, and then I will get through to your question. Okay.
Ma'am,
Yebo.
ma'am, you don't
Yes.
actually need to use a glass. You can use your bare hands. It actually is warm when you put it
Your bare
more
hands.
than,
No,
yes.
no. Why would you want to use your bare hands? You're gonna burn.
If you put it more than 30 centimeters away, it won't
That
be
is bad
hot.
advice. You are going to burn yourself. We cannot promote you guys burning yourself. How? That is so risky. No, you can't do that. But anyways, it is also much better to use a glass because you can see clearly on the glass what's happening, right? Because firstly, the glass will be mystified. There will be mist, and then that mist, you can see clearly that it is turning into water droplets. Okay, please do not burn yourself using your bare hands. All right. Okay, guys, please do not use your bare hands for that experiment. Okay, please. I see a question saying, what are bands? It was bare hands. Okay, bare hands, not bands. Bare hands, like just your hand. The question was referring to the activity, or rather the statement was referring to the activity that we just did. I think we also have a question here. Ma'am, why does the steam go to, okay, wait, why does the steam go to what, Toby? Just finish up your question. And then Bandila says, if you start fire, how does it make a gas? So if you start fire, how does it make a gas, or like the smoke? So remember, when you start fire, you are putting heat, or rather you are heating up two substances. Sometimes you are heating up wood, right? So wood also has certain gases which are in it. And when we put fire on the, or rather when we burn wood, the gases which were present in the wood, they form a gas and they evaporate with the smoke. Okay. Okay. I think I have covered. Okay, ma'am, why does this steam, where does the steam go? It goes into the atmosphere, right? Goes into the atmosphere, joins in with all the other gases which are present in our atmosphere. Okay, and some of it will condense, of course. Okay, guys, let us continue. So here is an example of steam and evaporation. And then we have another activity. In this activity, we'll be looking at melting and solidifying a substance. Okay, so the materials we're going to need is butter, fat, or margarine, chocolate, or wax, ice blocks or ice cream. But we will be using butter, chocolate, and ice blocks. Sorry. Then we have 3 containers which will not melt. Okay, then we also need 6 wooden pegs, a candle, matches, and here is our butter, our chocolate, as well as the ice cream that we will be using in this activity. Okay, so instructions. We're going to test each different substance that we have by placing it in the tin and holding it over a candle. Okay, and this is how it will look like. So we are going to put butter inside this tin, and then we're going to have another tin which has chocolate and another tin which also has ice. Okay, then we're going to remove the tin from the candle and leave it on the side to cool, and we need to observe what happens to each substance and write down our observations in a table. Okay, I think you guys have questions. Toby, I answered your question. And then I'm not sure if it's Lone or Natty who says, why is there steam? Okay, so we have steam forms because we have added energy to the particles of the liquid. Okay, we have added energy to the particles of the liquid, and the liquid is changing its phase. And Kiara says, ma'am, please go back. I think you guys want this particular slide. Okay. As I see Kingsley's mic, rather, raised his hand.
Hello, ma'am.
Yebo.
Ma'am, I was going to ask if you could come back to the slide.
Oh, okay. Okay. Okay, Dante says they have taught us about this and it's good to do revision. Okay. Okay, Nati, I see it. I will not forget it. Gabriel says, ma'am, okay, I believe you're saying heat and gas. Okay, Gabriel, please just rewrite your sentence. Right, so guys, I'll just give you a minute on the slide and then we will move on. Okay. Gabriel, just rewrite your question again for me. All right, so guys, we are moving on. Okay, just as I said, the instructions, we are going to test each of the different substances. Remember, I said we're going to use butter, we are going to use chocolate as well as ice blocks. Yeah? Then we're going to put those substances in a tin and hold it over a candle. Then we're going to remove the tin from the candle and leave it on the side to cool. Then we need to observe what happens to each of the substances. So this is basically what we're going to do. Here we have our tin, it has ice, okay, and then we're going to have another tin where we put in our butter and another tin as well where we put in chocolate, okay, and then our candle is just going to act as a source of heat, which will be located here at the bottom. Okay, so guys, if you are going to do this experiment at home, please ask an elder to assist you. All right, please ask an elder to assist you. Do not do it alone. All right. So, question, we will use our imagination. Okay. Some of you guys have done it, some of you haven't, but we can just make an educational guess. What happened when the solids were heated by the candle? What do you guys think happened to the solids when they were heated by the candle? Remember, our solids are the butter, the chocolate, as well as the ice blocks. Okay, so I see Loan, I think it's your name. You say they melted, and Bantila also says they melted. I'm not sure if I'm getting your name correct. And then Zoe has hand up. Okay, yes, so Yebo.
Ma'am, so all of them, because heat was added, the solids all turned into liquids.
Beautiful. So that means they melted, right?
Yes, ma'am.
Nice one. Thank you very much. Okay, so I see Unati, see Amange, and Dante. Thank you very much. Okay, guys. So the solids melted, all right? And then what happened to the substances when they cooled down again? So remember, we put them on over the candle, right? And after putting them on over the candle, we put them on the side to cool down. What do you guys think happened to the substances when they cooled down again? What do you guys think happened to the substances when they cooled down? So Bandile says they solidify. Lone says they froze. Yes, Zoe?
Um, they get back. They freeze and then they turn into a solid again.
Okay, beautiful. So beautiful, guys. Thank you very much for all your answers. I see all of them in the group, and you guys are most probably correct. The substances solidified again, or they froze. All right. Kingsley, your video is on. All right, guys. Next question. Did the ice cube solidify again, or did it remain a liquid? So now we're asking about a particular substance, the ice cube. Did it solidify again, or did it remain a liquid? Yeah, I see Gabriel's hand is up. All right. Yes, Gabriel.
They solidified.
The ice cube solidified.
Yes, ma'am.
Okay. All right.
Ma'am?
Okay, thank you very much for the answer, Gabriel. Yeah. Yes, I see Manager also has an answer. Okay, and Lone says it remains a liquid there in the group chat. Yes, Manager?
Ma'am, they are solidified. And ma'am,
The ice
isn't
cube.
this almost like the water cycle? Because the water cycle concludes evaporation, condensing.
As well as condensation. Okay, so now we're just looking at the materials around us. Okay, so now we're focusing on those around us and not living and life and living. So remember the water cycle, I believe it was under the topic of life and living when we looked at nature and what's happening there. Okay, so it also forms part of it. We do have a change of states which occurs in the water cycle as well.
But then how can evaporation or condensing be part of the wood, be part of materials around us? Because condensation is like when the water heats, and then after it forms the clouds, which is condensation, and then after it rains, and the rain, and then after the rain might turn into a solid, which is into ice.
Like
So
hail,
and then
when
after
we have hail, right?
yes, then after the sun heats it up and melts. Isn't it almost like
Sure,
that? Just
it
like
is
the
like that. It is like that, Meninje. That's why I'm saying that change of state also occurs in nature. Again, but we're also looking at changes of state that we also make. Okay, like for example, we taking the water into a freezer. So this is something that you do, and it is not a natural process that occurs. Okay, so you are applying the energy source, you are applying the heat source. And when we look at nature, the sun is applying the energy source or the heat source. All right.
Okay, ma'am. So then,
Sure.
but ma'am, even though you wear gloves, the gloves will also heat up, and maybe they might actually get a bit more wet onto
The
you.
gloves, are you talking about the experiment?
Yes.
But remember then the gloves, we said we use gloves with a thick material. So this is so that the heat does not move from the glove to your hand. Okay, so the glove will
Okay.
work as an insulator so that you do not burn.
Okay. So, ma'am, may I please go back to the materials that we need for the experiment? I didn't really
Okay,
get the picture.
okay, let me just finish up with these questions and then I'll go back now.
Okay. Thank you.
Sure. Okay, I see Taryn has a question, I believe. Let me just, or an
Answer.
answer actually. Yes, Taryn?
Remains a liquid because ice takes a long time to freeze.
Beautiful. Thank you very much, Taryn.
You're welcome.
Sure. Okay, guys, let's just continue because time is not on our side. Oh, sorry, guys, I wrote a wrong answer. Please do not write it solidified. It remained a liquid. Okay, so the ice cube did not solidify, it remained a liquid. This is the incorrect answer. Okay, the answer that's appearing on screen is incorrect. The ice cube remained a liquid. Okay, so guys, just important to also note that solids that have melted can be solidified again. So the process can be reversed or turned around again by adding or removing heat. Then we have temperature, okay? So now this is important. As we heard, guys, what Taryn answered and said that the ice cube remained a liquid. And I think some of you guys also wrote in the group chat that the ice cube remained a liquid. Yeah, I think, let me just go back here. Unati says, ma'am, ice cubes do not freeze if you put them in a cool place because they are not in the fridge. They will turn into water or they will actually remain as water. So guys, that is very much important to note. So guys, while other substances needed to be heated a while in order to melt, other substances need to be heated a while in order to melt. And then each substance starts melting at a certain temperature. Okay, so very much important to note that each substance starts melting at a certain temperature. And then this point is what we call the melting point of the substance. Right, so for example, you would need to put the chocolate for a longer time for it to actually turn into a liquid. All right. So very much important to note. And then temperature is measured in degrees Celsius. Okay. This is how you identify temperature with an instrument that we call a thermometer. And here we have an example of a thermometer. So guys, just to clear up on the question that we just answered previously about the ice cube, the ice cube would remain a liquid because when we cool down the ice cube, it needs a lower rather temperature in order for it to solidify. Okay. So I still need to go back to the materials page. Let me just do it now before we continue. Okay, so someone asked for the material slide. So here is the material slide. Just indicate to me when you're done so that we can move on and close up the lesson because I think we have 5 minutes left. All right. Toby, I'm so sorry that you're sick. I hope you feel better soon. Please do keep warm. Again. And then Nati says, ma'am, I gave you an answer in the group chat. Yes, Nati, I read your answer. Guys, please, no fighting, please. Okay. So I will move on, right? I hope, okay, I was meaning clear. Okay, cool. And we covered temperature, and we said the instrument that we use for temperature is a thermometer. And here we have an example of a thermometer. Gabriel, I see your hand. I will be with you shortly. Okay, so here is an example of how we would use a thermometer to measure the temperature. For example, it could be placed in a glass of water, and then the liquid inside the thermometer would rise to the temperature in which we find our water in. Okay, so thermometer usually has mercury inside, and the mercury would rise to the point at which the temperature is at, and that is how we measure or use a thermometer. Okay. Okay, so just quick question before we close. Do you guys know any other examples where thermometers are used? Do you guys know any examples where thermometers are used? And I'm just going to take 2 answers. I see Zoe, your hand is up. Gabriel, you had a question. So if you could just write your question in the chat, in the group chat, because I see your hand went down. Guys, let's use the group chat now just to save time. I see Nati says in the clinic, the known hospital. Right, and that is true, right? So thermometers are could also be used in ovens and where baking is required, right? And also in hospitals where we measure temperature of the patient, right? So just to check if you have a fever or what's going on. And if you guys have been to shops, I'm sure you have come across such a device. And this is also a thermometer, right? But this device uses infrared rays. Okay, so it measures your temperature and to check if you do not have a fever. Okay, guys. And yes, Unati, that is correct. They check your temperature using a thermometer. Okay. So guys, just a summary of what we looked at. We looked at change of state, a solid being turned to a liquid. And we said that in order for a solid to be turned to liquid, we need to heat it, and the process is called melting. In order for a liquid to go to a gas, we need to heat it, and the process is called evaporating. And in order for a gas to go to a liquid, it needs to cool, and then that is called condensing or condensation. And for a liquid to go to a solid is cooling, and that is a freezing or solidifying. So guys, this is very much important to note the summary, because it's just summing up everything that we learned today as well as yesterday. Okay. Hey guys, so thank you very much for joining in today's lesson and also participating in the group chat. So this is the textbook, guys, that was utilized for this lesson. As I did mention yesterday, you can get it online on the Thunderbolt Kids website. All right, so guys, if you do have any questions, you can email the school at stemdigitalschool@africateamgeeks.co.za. And here is my teacher information if you do have questions. So Dante, we do not have homework today, I'm sorry, but yeah. And guys, we will look at giving you guys time, Kahoot on Friday. So bye guys, enjoy your day further. And